Okay, so if we want to use the binomial theorem to work out this problem, 2x minus 3y raised to the fourth power, we need to look at Pascal's triangle. We need to pick out which row we're going to use of Pascal's triangle, and because we have it raised to the fourth power, we're going to pick out the fifth row. The fifth row is 1, 4, 6, 4, 1, and so that is what is going to become the coefficients when we set up our problem. Okay, so here we are set up. We've got our coefficients 1, 4, 6, 4, 1, and now we've got to figure out our exponents. Because the original problem is raised to the fourth power, we're going to start our exponents with 4, 3, 2, 1, 0 for the first set of parentheses, and then 0, 1, 2, 3, 4 for the second set of parentheses. Then we'll go ahead and set up the terms. 2x goes in the first set and negative 3y goes in the second set, all the way through the problem. Okay, once we have it all set up, at this point it just becomes a matter of simplifying. So the first thing we'll do is simplify the first term. This is 1 times negative 3y to the 0 is 1, leaving us with just 2x to the fourth power. Remember that we do have to square or raise the 2 and the x to both to the fourth power, so we have 16x to the fourth. Here, the next term is 4 times, again, 2x all raised to the third power leaves us with 8x cubed, and then times negative 3y. That is going to leave us with that is actually going to leave us with negative 96x cubed y as our second term. Here we're going to have 6 times 4x squared times 9y squared, which ends up leaving us with 216x squared y squared. Here we have 4 times 2x times negative 27y cubed. Again, that simplifies to negative 216x y cubed. And then down here, of course, this is 1. 2x to the 0 power is 1. And so negative 3y all to the fourth power simplifies to 81y to the fourth. When we put all of these together, our answer, final answer, is 16 x to the fourth minus 96 x cubed y plus 216 x squared y squared minus 216 x y cubed plus 81 y to the fourth. Let's try one that's slightly simpler. This is x plus 3 all raised to the third power. So again, because we're raising it to the third power, we're going to use the fourth row of Pascal's triangle. So when we set this up, we'll use the coefficients 1, 3, 3, and 1. Now, the exponents all are going to total 3. So we start with 3, 2, 1, 0, 0, 1, 2, 3. Notice that for every term, the exponents total 3. And that, of course, goes back to the exponent that we have in the original problem. Okay, and then what we're going to put inside these parentheses again is going to be x and 3, first term, second term, first term, second term, first term, second term. Okay, again, this is going to be 1 times 1, leaving us with just x cubed. Here we have 3 times x squared times 3 to the first power. Well, that's just going to be 3 times 3, which is 9x squared. Here we have 3 times x times 3 squared. Well, 3 squared is 9 times this 3 leaves us with 27. So we have plus 27x. And again here we have 1 times x to the 0 is just 1. 3 to the third power is 27. So that's how we work out the simpler version of the binomial theorem.